So, Michael, we're here at NodeConf live, which for me is, I'm just so happy to be back having conferences live. NodeConf was online only for 2 years. It's great keeping them online, but be here, like I can feel this energy with everybody, like, and being here, NodeConf, with so many members of the community who are so passionate about Node, JavaScript, technology. What brought you to NodeConf? Is this your first NodeConf, or have you been to NodeConf?
I started NodeConf, actually.
You are the founder of NodeConf. Well, that's a good, yeah, so tell me.
So no, I was actually the first one, I guess, at it. If that makes sense.
And the original NodeConf in the United States before they had the European edition. Okay.
Exactly.
Wow, okay. So you are Mr. NodeConf here.
Not anymore. I don't run them anymore, so you know.
Yeah.
Kian's definitely got the flag now.
Yeah. So have you been to all of them in NodeConf EU?
No, I went to all the ones I believe in Waterford, at the castle, but I haven't been here yet. This is my first time here.
And so what do you think being here?
Oh, this is nice. This is nice. I do love the castle, though. I mean, the castle's great. Yeah.
Some charm about being in a castle.
Yeah.
So I know that you're passionate about Web 3.0, peer-to-peer, IPFS. So, like, what is IPFS? If anyone's like listening to us and they haven't learned yet what IPFS is.
I mean, there's many complicated ways to explain it.
Sure.
I think that the easiest way to explain it is that it's like URLs for data.
Yeah.
Okay. So, problem with using actual URLs for data is that they say, go over here on the internet to get my data.
Yeah.
Right? So whenever we have data in our applications, whenever we send data to other people and we use these references that say, go get it over here, we kind of lock into this particular provider providing that data that particular way, right? So what sort of cryptography and like decentralized systems give us is a way to verify data without going through that, right? So there's no blockchain involved in any of this or anything like that. It's just, it's a hash of the data, right? So anyone who has that data can give me that data, and I know that it's the right data, right?
Because you can validate the data and see if you get the same hash that you're looking for.
It's the same way that Git works, the same way that BitTorrent works, right? It's all the same kind of underlying.
A lot of the technology we already know and love.
Exactly. But I think IPFS just went the extra mile there in really figuring out, well, what should the address look like?
Yeah.
So not just files, but just kind of all data, all different types of data that you would ever want to hash address and link that way.
Okay, yeah.
So there's a really sort of advanced linking format inside of the CID. But the easiest thing that you do with it in the IPFS tooling is just make files and upload files. But you can also upload all kinds of semantic data, all kinds of other hash address data. Yeah.
And you think there's going to be a lot of like new ideas and new uses for like this type of technology? I mean, can you give us like some insider sneak peeks at what do you think is like coming in this domain?
Well, we've already seen a few things happen.
Like
right?
what?
Like, well, I mean, the NFT boom was very interesting, right? Because it showed that there was just a huge community of people that wanted to create something that they didn't feel like they had a way to create it before in the old technologies, right?
Yeah.
So you had this explosion of like new images that were being created and presented in a particular way to be sold and traded. And we built NFT.storage to just like handle the storage piece of that. Because the blockchain part is actually like not that complicated. It's just a little contract that says this person owns this number and this person owns that number. But the actual asset data, the file, the video, whatever the NFT is about, that needs to just be available in the public network. And the way to do that, and the blockchains don't want to store that much data, like actually on chain.
This is really expensive to...
Yeah. What they want to do is they want to take a hash of the data and say, oh, well, this is where you go and look that up. This is how you go look that up.
So they're going to store the hash, and it's IPFS that's going to store the actual data itself?
Exactly. Well, actually, so they made the spec very flexible. So it's actually just a URL to the metadata. But because we have, IPFS gateways that take the HTTP transport and the IPFS protocol and just put it into the HTTP transport, we have a way to interop with that transport.
So this is like the gateway between, we're going to use buzzwords like Web 2.0 and Web 3.0 is an IPFS gateway.
Yes.
So this lets you like use IPFS in an existing application today that's maybe Web 2.0. But I saw your talk or your workshop today, and like there's already like JavaScript APIs to integrate with this.
Well, and the beautiful thing is that those JavaScript APIs will upload into our service like right away. From any client device, you don't have to hold bearer tokens or things like that. We have a nice decentralized permissioning structure. But also, they're in an IPFS gateway, right, when you upload them, and that gateway is in a CDN. So all of the data that you ever upload is just available in a CDN. The nice thing about working with hashes is that they're really easy to cache.
Okay, yeah, it's helpful, yeah, exactly.
And the other cool thing, too, is, when you're using those gateway URLs, those HTTP URLs, even in protocols that need HTTP URLs, that hash address is in there, and you can inspect that URL to tell if it's the hash address in there.
Okay.
So there's a virality to the IPFS protocol going into the URL that kind of takes it from a centralized transport to a decentralized transport.
Okay.
Because you can literally parse that HTTP URL and just turn it into a decentralized identifier.
Yeah, exactly.
Really, we do it all the time when we scrape the chain data. So.
And so is this using Elastic-IPFS behind the scenes?
Yeah, we couldn't get anything. We built that Elastic-IPFS because we couldn't get the prior implementations of IPFS to scale to the needs that we had.
And that's why it's Elastic, because it's growing. It can scale to whatever.
Exactly. Prior implementations of IPFS, they have a very similar model to what you would expect out of, say, a BitTorrent or also like a blockchain miner, right? Where you have a node that someone runs, and that's staying on the network and keeping that content alive.
Right.
And most people are on devices and laptops that they're closing and aren't on particularly reliable internet connections.
Yeah.
So they really want to hire someone to hold on to the data and make it available for reliability reasons. They may also still want a copy locally. That's the great thing about these protocols. You can still have all these local offline copies. That works great. But you can also just kind of push the data to us.
Put it into the IPFS. And so are you pinning that data too? I don't know if I'm using the right terminology.
Well, pinning is a term that was sort of coined by some of the early IPFS workflows.
Explain a little bit that term and maybe how it's changed.
Yeah, I mean, we tend not to use it anymore because there's a lot of implications behind it that aren't necessarily true. A good example here is, you've got a really big file, right? And so that really big file, of course, has one hash address for the top of this big tree, this big Merkle tree, right? Same way that, your whole Git state has one hash associated with it, right? So it's a big state associated with one hash. You probably don't want to move around or upload or update the whole thing every time. Sure, yeah. And the thing about pinning is that it kind of assumes that you're always holding whole copies and working with whole graphs. Because there's an implication that when you pin it, you want to pull the whole graph.
Tree or the whole graph of the...
And what we find is that, one, pinning really requires that you already have an IPFS node running like a custom transport protocol. And if you're hiring us to put the data into IPFS, you probably aren't already running that protocol.
Yeah, exactly.
But also, when we get our client library today, if you put a really large file into it, we break it up into slices to upload just to make it reliable and make resumes work and all that kind of stuff. And so we're also not using pinning there. We're actually taking slices of that whole graph and uploading them a part at a time.
And I saw today we had the CLI, the Web3 UI CLI. So this is going to help me run access Elastic-IPFS Web3.storage from a server application, right?
Or just in the browser, right? Because all it has to do is talk HTTP to our end, right? It doesn't have to run any kind of custom transport. Really, the real work that's going on in the client library is just taking the original file data and turning it into that tree, that nice Merkle tree that we can do nice diffs and decentralized stuff on. And it's really important to us that happens in the client, because if you were to hand us the file and we told you what the hash is, you're trusting us.
Kind of going back to a different model that we're trying to move away, right?
This is a service, we are providing a service to people, but we feel very strongly that we should only work in decentralized protocols so that we're not locking you into a service. And also, as we have to run our service in different POPs, we have code in Cloudflare and code in AWS, and we'll probably have code in Azure at some point, right? Sure. We like to have a decentralized protocol to work around, right, and move everything around. So we really like it that you encode that locally, and then so when you give the data to us and you grab it by hash, you can validate that hash. It's verifiable. You didn't really have to trust that we did anything. You can always verify that we did what we say. And when you're working on these more advanced Web3 applications where you need to take that hash and then use it for something on chain, you get it right away before the upload is done. So you can start to put together the rest of the work that you're going to do before all of the other transactions finish. And that's how you start to speed up a lot of these user interactions as well.
So I just wanted to go back to the workshop, and I know the workshop got recorded, so we can check this out later also. But there's also like a set of components, so people could start using this in front-end applications like now, today, right?
Yeah, I mean, the beauty of this, and the sort of slogan for Web3.storage is data anywhere.
Ooh,
right? Because the
I like
thing
that.
about these hash addresses is that your data can be anywhere.
Right.
And so please give it to me wherever it's closest. That's kind of like the main thing that we're selling and that we're kind of talking about here, right? Is like my data anywhere.
Yeah.
And that's the whole vision of it. And the beautiful thing about that when you think about UI components and how to program on the web is that you load up a web widget wherever someone is in the world. And if the data and all the addressing is built in such a way that we're not thinking about regions and locations and this kind of thing, you can just load these widgets that we provide to do all the work for you. And as we get on more advanced use cases, like some of these database use cases that we're looking at, it's the same kind of thing where you just like, oh, well, if you know what your query is, then here's a widget that throws the query, like go ahead and style it.
Oh, that's amazing.
Yeah.
Okay, so just in the last minute before we wrap up, can you give us any teasers about what might be coming in Web3.storage or no pressure.
That's a good one. That's a good one.
Or maybe some use cases you see for this.
Yeah.
That aren't secret ones. But,
I actually can. So, because I'm working on this code right now. Actually, I was just writing it while we were in the other room. It's called Web Deltas or Web Delta Protocol. And basically, this is it's the IPFS file protocol. So it's the same data structure for IPFS files.
Yeah.
The files that this produces can be read out of the gateway the same way that I've been talking about. But I do something kind of special when I create this tree. There's something that Git does called content-defined chunking. This is how Git does really nice deltas. It uses this chunker that just tends to break in the same places with the same text. So as you edit, only the blocks around your edit effectively end up getting changed, right?
Yeah.
But there's some new work that I did a couple years ago implementing these new trees called Prolly trees. They're probabilistic B trees. And they do that same kind of content-defined chunking scheme, but in the tree that exists on top of the data to sort of show you all of the sequentiality of it, right? So I have an implementation of the IPFS file tree that uses that Prolly tree strategy. And that's really interesting because now we don't have to think about or worry about the tree shape and encoder settings. It's just uniform from every file that we ever use with this tool. And that means that any file you can create a delta from an old state to a new state and ship around the delta. And you can push the delta as a car file to our service. You can get the delta out of our service in one round trip for any delta.
Some really interesting use cases that can come out of that.
So you basically get style deltas, but you get them at the individual file level without repos, without namespaces. You can just say, oh yeah, you have that old file. Here's this address. It's like a big hash, and you can just go and apply that delta, and it'll be the fastest way to do that operation that you can imagine. And the nice thing about this sort of uniform tree strategy is that you never have to keep a block store any state other than just the file data itself. You can always reconstitute all the blocks from the file.
That makes sense. Mikeal, there's just so much to talk about. I'm so excited about this domain and what's going to come in the future. Thank you for taking the time to talk with us. Thanks for being here at NodeConf, the founder of NodeConf. It's a privilege to be next to you. And look forward to seeing you soon and enjoying the rest of the conference.
Awesome. Yeah, thank you.
Thank you.